Hello and welcome to the heat and Q equals MC delta T screencast. I'm Mrs. Willie and let's get going. So before we get going on our new formula Q equals MC delta T, I want to refresh your memory on the unit for energy and dimensional analysis. So the SI or System International unit for energy is the joule, which is a capital J. We will also be using the heat calorie or the calorie with a small or lowercase c. That's known as the heat calorie. The heat calorie is the quantity of heat needed to raise the temperature of 1 gram of water by 1 degree Celsius. So you will need to know this conversion factor of 1 heat calorie is equal to 4.184 MC delta T, where Q is the variable heat. We've spoken about Q in the last screencast, so this is that heat transfer. If it is a negative value, then your transfer was exothermic. If it is a positive value, then your transfer was endothermic. The variable M is equal to mass of the substance in grams. C is equal to the specific heat of your substance, and it has the unit joules divided by grams times degrees Celsius. And delta, the triangle means delta, which is the change of. So the change in temperature, and it's the difference in Celsius temperature from the final temperature to the minus the initial temperature. So Q is the thermal energy gained or lost by the system in joules through heat transfer, conduction, convection, or radiation. Y is mass in the equation. The more atoms or molecules present, the more energy is lost or gained by the system. So I can affect Q by how much mass I am putting into my system. The heat capacity, or C, is the energy needed to raise or lower the temperature of a substance by 1 degree Celsius. So throwback to unit 1, joules over grams is an intensive property because it is a ratio. So I can use heat capacity to help me to determine what's going on. The specific heat capacity is an energy needed to raise or lower the temperature of 1 gram of the substance by 1 degree Celsius. So again, throw back to unit 1. This is an intensive property, and this should be a multiply. Because this is a ratio, this does not rely on how much is present. So I can use specific heat to help me identify substances. Y is specific heat capacity in the equation. Metals tend to have very low specific heats. They are good conductors due to their sea of electron structure. Nonmetals tend to have high specific heats because they have the lax of flexibility in their structure. Water and ice have very high specific heats because they are made of nonmetals. We use them a lot in a lab technique called calorimetry, which is what we're going to learn about in 5.02. So Y is delta T in the equation? Final minus initial of the system. The delta T gives you a sense of whether the change of the heat of the system is endothermic or exothermic. So if the final temperature is lower than the initial temperature, then the system lost heat and Q should be negative. It was exothermic. If the final temperature is higher than the initial temperature, then the system gained heat and the Q is positive and the change was endothermic.